Have you ever wondered, does she still think about you sometimes? No, she doesn't. Anyway, in this video we're gonna talk about the source code of Command & Conquer Red Alert 1. Red Alert was like a fever dream. Now looking back, it was kind of a Balkan simulator. You had attack dogs, you had thieves, you had Tanya shooting up the place, and the certified Balkan hood classic, landmines, and a bunch of other things which are banned by conventional warfare. I mean, what does conventional warfare even mean in 2026? Anyway, in this series I analyze old RTS game engines and draw universal lessons. In the first part I talked about Tiberian Dawn, which came out in 95. In 96, Westwood shipped Red Alert. So from a development point of view, you have a very narrow time frame, and we can see how the code evolved in just 1 year. They added new features like the Naval Units, ships and submarines, they changed how the game data assets work under the hood, and so on. Now, a huge thing you gotta keep in mind is that this was a time period where you could not ship half-assed games like nowadays for the full price and then promise patches later. The game had to work out of the box, like literally. All of these factors combined make this comparison an extremely valuable lesson, which unfortunately many developers are still struggling with without even being aware of it. The lessons are not about syntax, frameworks or languages, they're about software engineering. So grab your food, get a drink and lean back. This is Command & Conquer Red Alert. So today I'm gonna walk through some of the code sections, compare them to the previous game, and we're gonna discuss what has changed. During the video I will be using SourceDive. Don't worry, it's not a sponsorship, bro. I just vibe coded this extension in my free time, and in case you also wanna flex around colleagues, you can get it for free from the extension marketplace. It is completely free, and if you wanna buy your bro a coffee, feel free to do it. Just remember, I want a cappuccino with no sugar. SourceDive can do a bunch of cool things. I designed it around my use case for analyzing stuff in teaching, but you will see it during the video. Okay, in this part, first we're gonna talk about how did they introduce the Naval Units. Then we're gonna talk about what has changed in the mix and the rules.ini files. And then we're gonna take a look at the function.h monster header file again. Now, first let's do a quick recap of the architecture and main loop. From the architecture point of view, Red Alert compared to Tiberian Dawn is basically the same game. Same, but different. I'm just gonna draw a quick diagram for the people who have not seen the previous video. So Red Alert is a game. We have inputs, keyboard, mouse, network packets. Then we have the game engine. Then we have some game assets, which in these early Command & Conquer games are stored in the so-called mix files. And then we have outputs, such as visual output on the screen, audio, and outgoing network packets. This is the big picture. And from Tiberian Dawn in 95 to Red Alert in 96, that big picture did not really change much. Some systems got improved, some parts got extended, but the foundation stayed the same. And that is the important part here. Now, when it comes to the main loop, the point here is actually really simple. Red Alert compared to Tiberian Dawn keeps basically the same main loop structure. They did not redesign the runtime, they kept the old backbone and just sprinkled some extra functionality on top of it. So even right at the start, this does not look like some brand new architecture. It is still the game getting into the loop, doing a bit of housekeeping and preparing the frame. The only difference is that Red Alert has a bit more session and debug bookkeeping attached to it. So at the runtime level, the sequel is still very conservative. The backbone stayed the same and Westwood didn't burn time in redesigning it. Okay, now before we get into ships, this is probably the cleanest place for the first big lesson. Scoping. Scoping a project properly is one of the most important skills you can learn as a developer. By scoping I just mean deciding what actually makes it into this milestone, this version, this release. Sounds simple, but most people are terrible at it. Because the mistake is always the same. You get hyped up, you wanna implement every feature, everything the competition has, but better, faster and somehow in less time. And then what do you actually ship? A little bit of everything, but nothing is really finished, nothing is really solid. So scoping is basically budgeting with time. You're deciding what can realistically be done well with the time and resources you actually have. And that skill mostly comes from the experience of finishing projects. It does not even matter what your project is. Just finish. Finished projects teach you where you were lying to yourself. And companies do this all the time. Management ignores the developers, promises the moon to impress somebody upstairs, and then the developer team has to deal with it somehow. Listen, if you invite me over for dinner and serve 5 half-baked meals, I'm not coming over ever again. I don't care that technically speaking there's a lot of food on the table if nothing is really done. But if you tell me, listen bro, I only made fries tonight and those fries are slapping, now we talking. And that is project scoping. It's better to ship one thing that is actually finished than 5 things that are all kind of working, kind of broken. And Red Alert is a pretty good example of that mindset. I mean, they knew that naval warfare would be cool in Tiberian Dawn. Maybe some version of that idea was already sitting there in the background. But the practical move is what matters. You do not cram every good idea into release 1 just because it sounds exciting. Sometimes the smarter call is to ship the core that works, then use the next release to add the feature with enough room to do it properly. So with that in mind, first we're gonna take a look at the naval warfare units. When comparing Tiberian Dawn directly with Red Alert, naval units are one of those differences Red Alert gets remembered for. Now, most people would assume Red Alert solved the ship question in the obvious way. Take the existing unit class, add some kind of naval flag, let a few units move across water, and then keep stuffing special cases into this old unit code until it more or less works. But that is not what they did. Basically, think of it like this. Instead of teaching the existing unit type to pretend it is a boat, they added a new type that will own that naval behavior. From a development perspective, what matters is that they change the object model without reopening the whole land unit path. Now let's take a look at the code and how that looks in practice. So first they add the new runtime types. And by adding these two, vessel and vessel type, the engine is already saying we have new types for ships, we are not refactoring land units. And if you now take a look at the drive class, which is the parent class of unit class, you will see how vessel also inherits from drive. Now let's take a look at the unit class and the vessel class next to each other. And as you can see, they look kinda similar. And now you might argue, but that's repetitive code and they are violating the don't repeat yourself rule. But this is the whole architectural move. Unit class stays the land path for land units and vessel class becomes the naval path. Both still hang off the drive class, so they share the same movement logic. And this is one of those engineering patterns that keep showing up. When you want to add a new feature, you usually have 2 options. You can go back and refactor the old system so it becomes more universal, more elegant, and capable of handling the new thing. Or you can leave the working path alone and add a new path on top. And a lot of developers pick the first option because it feels smarter. It feels like the architect move. Clean, principled, reusable. But in real projects, that is often the riskier choice. Because now you're not just adding a feature, you're rewriting old behavior that was already working. And that is how one new feature often turns into a full system refactor. Listen, sometimes the better move is to accept a little duplication, create a new type, a new path, or a new layer, and keep the old system untouched. Is it as pretty? Maybe not, but it keeps the blast radius as small as possible. And that matters a lot. Because if the new feature breaks, you are debugging the new feature, not the whole system. And if the old system was left alone, you are much less likely to light the rest of the project on fire. Remember, not every new feature needs a universal redesign. Sometimes the smartest move is to bolt the new thing on top and keep moving. And in Red Alert, that is exactly what the split between unit class and vessel class is doing. Now, second thing is, once you create a new type, you have to give it the rules that make it a real counterpart, not just a new class name. the map and the mission layer have to understand water. And on a top level, the mission and map layer are responsible for the unit movement. In my last video, I showed how a click becomes a movement intent, and that's then translated into a mission, which is basically sending the unit on a mission, so to speak. Now we have different movement types. We have normal, crusher, which was introduced for tanks so they can crush crushable wall types, and destroyer. There was also a discussion how some heavy tanks were initially designed to be able to crush smaller vehicles. Okay, and then we have to add this water movement, mzone water, for water-based objects. And now if you take a look again at the vessel class, you will see this. Zone check type return mzone water. This binds the vessels to water. Furthermore, the class exposes naval-specific behavior like combat, repair, retreat, and so on. Okay, now the new unit type also needs its own units and its own production path. So if you open this, you will see the naval units being defined here. Submarine, destroyer, cruiser, missile, blah blah blah. So we have the type, we have the rules, and we have its units. And now we need to be able to build these units somehow. So the house gets a dedicated naval production slot. And that is basically how ships become a full counterpart to land units. They get runtime identity, their own object branch, their own movement rules, their own units, and their own build logic. The downside of this is obvious. I mean, you get a bigger object model, you have another type to maintain, but for a sequel with a narrow time frame, this is a very sane trade-off. The concrete payoff is that naval repair, naval movement, and naval production mostly stay on the vessel side. So when the new water feature breaks, you are testing the new water feature, not reopening the entire land unit system. Making good calls for these logical decisions requires time. I mean, the chance that you will get everything right in your first project equals 0, but you can actually train this muscle with exercise. A lot of this skill comes down to training to think clearly, not just looking at the problem longer, but actually learning how to split it into smaller parts and solve it step by step. What I like to use to sharpen my logical thinking skills is Brilliant. Brilliant teaches math, logic, and coding through interactive lessons where you actually solve the problems yourself. That is what I like about it. It's not just passive learning where you just sit there watching videos and pretend you're doing something useful. You have to engage with the problem. The lessons are built by educators from places like the MIT, Harvard, and Stanford. The courses are basically for anyone from the ages of 10 to 110. I especially like the courses on geometry, probability, and algorithmic thinking, because they train exactly the kind of problem-solving skills you need for these kind of situations. To learn for free on Brilliant for a full 30 days, go to brilliant.org/Tariq10x, scan the QR code on screen, or click the link in the description. Brilliant's also given my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Okay, now let's continue with the mix files and rules.ini. So when talking about the game assets, we need a Tiberian Dawn comparison right away. In Tiberian Dawn, if you want to change something, like unit build prerequisites, you are opening source files like udata.cpp and editing the type table directly. For example, if you take a look at this flame tank unit, you can see it right away, the rule is sitting in the code. Build level and building prerequisite are part of the unit table itself. Now let's take a look at the same section in Red Alert. And here we go. As you can see, in Red Alert, we don't have this per unit prerequisite anymore. I mean, it still has this tables in udata.cpp, but this file is no longer the place where those gameplay rules are authored. And that's the difference. So in Tiberian Dawn, you can change those rules directly in this part of the source code. And Red Alert moves this out of this file. I mean, those ini files are not something new in Red Alert. Tiberian Dawn also had the ini files, but now the ini files get much more responsibility, so to speak. And that's what they changed. Instead of parsing options and feeding rules scattered amongst files, Red Alert boots a dedicated rules database and processes it. And if you take a look at the code, so rules.ini is not just a text file the engine glances at once, it is the file from where Red Alert just pulls out the rules, and that is the actual shift. So in Tiberian Dawn, if you want to change the rule, you added udata.cpp. In Red Alert, you just added rules.ini. So the rules per se did not disappear, obviously. It's just that the editing surface moved, and the runtime still consumes the result the normal way. And that is why rules.ini became the famous tuning surface in Red Alert. But why does that matter? That matters because now you do not have to go back into the source code and recompile the whole game every time you want to change a game rule. You change the data, the engine reads it at startup, and the existing runtime keeps working with the new values. This is basically what all of the games are doing nowadays. You have the engine part, and then you have the game data assets, the rules, and you can change the rules without needing to recompile the whole game in most cases. Now let's talk about the mix files. So in Tiberian Dawn, the mix file class is very straightforward. How many files are in the archive? How big is the data? Where is the table? And did we cache the payload? Red Alert reuses the same basic idea, but the archive object knows more about the package. So in the new mix file class, the class can track whether integrity data is attached, whether the header format is extended, who owns the cached memory block, and most importantly, where the embedded payload actually begins. So this is the practical upgrade. Red Alert reads the header table into its own buffer and records the real start of the embedded file data. And that gives the rest of the file layer a cleaner contract. So when we have the rules and the mix files, we can put 2 and 2 together. You can think of it basically like this. So mix files is the game data, what units do we have, and rules.ini is like the rules of the game. What prerequisite do I need to build a, I don't know, flame tank? And now you're probably wondering, but Tariq, what if I just take my rules.ini file and change it to whatever I want? Well, it's not that simple. When a player joins a game, the game sends an ID for the currently loaded rules.ini. Then the host checks whether that ID matches its own. So if one player changed rules.ini arbitrarily, the game does not try to work around it. And it does not try to merge anything, it just rejects the player. So once the developers moved more gameplay rules into rules.ini, they also had to make sure multiplayer clients were all using the same version of that file. And that's how they did it. Now let's talk about the notorious function header file from the last video. In my last video, a lot of people pointed out that function.h looks like a precompiled header. Or maybe just is the precompiled header. And that is a very reasonable first read. But now, if you check the makefile, the project really does define one under conquer.pch. Use precompiled headers. Let's briefly talk about what precompiled header files are and why function.h exceeds the scope of a, let's say, classic precompiled header file. A precompiled header is basically a cache of compiler work for shared header code that gets included in many files and usually stays the same. In a big C or C++ project, a lot of source files start with the same setup. System headers, platform-specific definitions, compiler-specific setup, common macros, and so on. Now, instead of parsing that same shared header prefix from scratch in every translation unit, the compiler parses it once and stores the result as a precompiled header to reuse it later, as this .pch thing. And that is where the compile speed gain comes from. But now what breaks that cache is when that shared header prefix stops being stable. If you change macros, the include order, compiler options, or declarations that affect that specific prefix, that cached result becomes invalid and the compiler has to rebuild it. And if you open the code, the project really supports that story because a bunch of CPP files in code include function.h directly. Now, I don't want to be nitpicking, but it's important to mention the boring fact that the actual precompiled header artifact is not the source file itself, okay? In this build creates specifically this conquer.pch precompiled header. The function header is just one of the big shared headers that feeds into it, okay? So yes, function.h is part of the precompiled header story. But if you want to know whether that label really explains the file, the only honest way to do it is to open function.h and scroll from the top, and you will see what I mean. Okay, let's start. So right at the top, the pro argument looks really strong. This is the normal umbrella header stuff. We have an include guard, project-wide policy macro, no drama yet. Then before the real include wall even starts, there is really another little tell hiding near the top of the file. Now if you look at this block lives under if def never, so it is not compiled. But it still tells you something important. Even the comments section is using function.h as a place to explain the class model. It's the documentation. The code is the documentation, okay? So the file is already doing more than just dumb build setup. But stay with me, we're not done yet. So we scroll a little further and hit the part that really does look like a classic precompiled header material. So this is exactly the stuff you expect in a precompiled header-friendly umbrella. Compiler glue, platform setup, and compatibility definitions shared across a huge chunk of the program. Now, if you stop reading around here, calling function.h a precompiled header style header would be completely reasonable. But the problem is it doesn't really stop here, okay? So let's continue. Now, the deeper you scroll, the more you realize that function.h is just getting more and more jobs. It's like on your job. When you finish your job too early, then you suddenly unlock other people's jobs too, for the same pay, of course. So now we are not just setting up the world before the real code starts, we are defining project types directly inside the umbrella header. And it does not stop there, okay? Right after this section, the file adds a custom no-init class helper. Then it keeps pouring more shared definitions and more includes into the same stream. A little further, then if you continue scrolling, the file starts mixing subsystem includes, runtime globals, and declarations all in one place. And that is where the whole thing stops feeling like a clean cache boundary and starts feeling like the front desk of the whole company. Then further down here, then it starts like rewriting behavior policy too at this point. Okay, this is not passive build plumbing anymore. This file is deciding what assert even means on Win32, okay? And then literally a few lines later, it turns into a declaration directory. Okay, and that keeps going for page after page. At that point, it's just a precompiled header reading really doesn't pass the test, at least not in my books. A clean precompiled header input is supposed to be boring, but function.h is doing everything. I'm sure if you keep scrolling to the bottom, it would also make a coffee and clean the lunchroom at some point. But you will see in a moment something even more interesting. Just stay with me, okay? So, as I said, precompiled header only really pays off when the shared front section stays stable. Function.h does not. And now, the strongest argument here is not my interpretation. It is the code flat out telling you what the problem is. For example, check this out. If you open now ccdde.cpp, whatever that means, you will find this comment. misc externs, so we don't have to include function.h. Read that comment again. So we don't have to include function.h. That is brutal, okay? And that is definitely not how we talk about a cute little convenience header. That is a source file actively avoiding the dependency. They would rather manually spell out a few externs than pull in function.h. Function.h is like the guy in the friend group where you, because of him, have another group chat, but without him. You don't want him to be there every time you hang out, okay? So this guy is trouble. He starts fights, owes everyone money, and he's just too loud all the time. Okay, jokes aside, this comment for me, it's one of the strongest pieces of evidence in this whole argument, because it's not my interpretation putting in words in the codebase's mouth. The codebase already said it. And I have another piece of evidence. So if you open now the to-do text, the project gives you even one bigger clue. Let's take a look at this file. Abnormal program termination created 100 meg precompiled header file. That is the other half of the story. Yes, the build still wants the compile speed win from a precompiled header, but the shared header sitting in that workflow has become huge enough to spawn nodes about the 100 meg precompiled header file. And that is where the bigger lesson actually comes. One of the easiest ways to derail a project is to pick the wrong refactor at the wrong time. You look at some ugly old subsystem and think, this is a mess, we should clean it up, and then you completely underestimate how much hidden behavior is packed into that mess. Because ugly code that works is still ugly code that works. It may look terrible, but if it has been sitting in production for years, it is probably carrying a bunch of weird assumptions, edge cases, and undocumented dependencies that nobody fully remembers or understands anymore. The moment you decide to clean it up, you are not just changing the style, you are gambling with the behavior. And this is where projects get stuck in the worst possible place. You cannot really go back because now other people are waiting on your refactor, but you also can't finish it cleanly because halfway through you realize the old system was ugly for a reason. And sometimes the smartest move is not to touch the ugly thing at all. Wrap it, isolate it, document it, study it, put a sticker on it saying don't touch it, but do not rip it apart just because it hurts your feelings because it's ugly, okay? Not every mess needs surgery. Sometimes your best bet is to use what is there and just move on. And if you ask me, I would never ever in my life volunteer to refactor function.h. And in this codebase, that is exactly the vibe. By the time other files are leaving workaround comments and the compiler is choking on a gigantic shared header, you are no longer looking at a cute cleanup task for our new intern who came this week, okay? So in conclusion, if someone calls function.h a precompiled header, the honest answer is kind of, in workflow terms. But that is not just a cache boundary anymore. I mean, in the case of function.h, that is a build-wide dependency seam. And once you start seeing comments in other files about this file, the file is basically making the case against itself, okay? I mean, precompiled headers can be a great thing, especially in industries like embedded, automotive, where you have some legacy systems, unoptimized compilers which fulfill all the safety standards, but precompiled headers have to stay stable to serve its purpose. Anyone who worked with, I don't want to mention any companies, but let's say safety critical embedded development, aerospace, automotive, medical, knows how much precompiled headers can speed up the workflow. Okay, that's not even a question. Conclusion. If we look around for the past 20 years, everyone knows at least one game or one software application where the company promised a bit too much. Then comes the release, and all of a sudden out of 10 core features or game mechanics, 7 look very unpolished. As I said in my last video, it is rarely the case that the developers did not know how to make it better. It is almost always the tight time constraints. Now listen, I don't know any project that has failed where one of the reasons was not we did not have enough time. It is very rare, or at least I have never heard people say, well, we had all the time in the world, but we were just not competent enough to make it work. And I know how it goes. You start a project, you have many ideas, and you want to let your creative side shine, and then you try to put everything you have, your whole heart, into this one project. You start creating a vertical slice of the product, you start creating a proof of concept, and of course, you do not polish everything to the last bit. You cut corners, which is completely reasonable. Then the phase comes where the prototype has to become a real product, and you realize it is just too much. Too many features, too many dependencies, and not enough time. And that is the moment when you have to play keep or kill with your project. But many developers do not have the heart to start cutting away features because deep down they know they could pull it off, but time is very ruthless. And what happens then? They ship something that is fully half-baked. You have a really big feature scope, but nothing is really working. And that is the lesson not everyone learns. You have to scope your project properly. That doesn't mean you completely ditch 90% of the features just to ship something that, well, works, but it doesn't bring any value at all. No, you have to understand that people value things that work in the way they expect. If you are a first semester engineering student, write this on the first page of your notebook. Quality always wins. Nobody cares about a great presentation if the product is dog shit, and I am completely aware that people still buy things where the presentation is good but the quality is just bad. But if you want to be any sort of engineer, you should strive for excellence in your craft. If you cannot ship all the features you had in your mind, do an impact analysis. What if I remove 2 features? Will the other 8 then become much better? Where is the sweet spot? There is always a scope factor where you know that this is the best overall package you can pull off with your resources and your time. Nobody cares that everything almost works, kind of works. When I buy a game, I expect it to work. It does not need to be maxed out in every aspect, but it has to work. Same goes for anything in life. Imagine ordering food and all the food is almost cooked properly. The fries are cold, the ice cream is melting. I would rather have them tell me they are out of ice cream and then have like the best fries I ever had. You get my point. Anyway, now I want to take the moment and say a big thank you to my Patreons and YouTube members. If you want to support the channel, you can become a Patreon or YouTube member. I want you to know that your support really helps me create better and better content. All your feedback, messages, emails, comments really mean a lot to me. The SourceDive extension should be released by now, so head to the Visual Code Marketplace, download it, and let me know what you think about it. So that's it for today. If you like the content, hit like and subscribe, and see you in the next one. Tariq 10X.